This is SpaceTime Series 25, Episode 44, for broadcast on the 13th of April 2022. Coming up on SpaceTime, solar orbiter's closest approach to the surface of the Sun, the Artemis 1 moon rocket test scrubbed, further delaying any future launch, and NASA completes another stage of the James Webb Space Telescope's complicated mirror alignment sequence. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The joint European Space Agency NASA's Solar Orbiter spacecraft has undertaken its closest ever approach to the Sun. The historic perihelion passage, which is well inside the orbit of the planet Mercury, saw all 10 scientific instruments aboard the probe operating simultaneously to gather as much data as possible. These included the Extreme Ultraviolet Imager remote sensing instrument and in situ instruments designed to measure the constant stream of charged particles flowing out from the Sun in the solar wind. Solar Orbiter is getting as close as 42 million kilometres away from the Sun. That's about a quarter the distance between the Sun and the Earth. There, it'll soak in scorching temperatures of up to 500 degrees Celsius. Observing specific properties of scientific interest on the Sun required close coordination between flight control teams and flight dynamics experts at ESA's Mission Control Center in Darmstadt, Germany, and solar orbiter scientists at the Mission Science Operations Center in Spain. Mission managers used the full-disk telescopes aboard Solar Orbiter to identify dynamic activity like moving sunspots on the solar surface. This required using specific locations in order to calculate accurate pointing of the narrow-angle imager for more detailed observations. Now, since the instruments are all fixed in place across the spacecraft's body, the entire probe needs to be manoeuvred in order to get the right sensor pointed at the right feature at the right time. This ongoing cycle of using wide-angle images to select specific narrow-angle targets, then feeding the needed targets back into flight control instructions, is a constant for the solar orbiter teams during this phase of the mission. Meanwhile, other teams of scientists are already studying recent solar orbiter images taken as the spacecraft crossed directly between the Earth and the Sun. The stunning images show the full Sun in unprecedented detail. The observations taken by the Extreme Ultraviolet Imager are providing scientists with the highest resolution images of the Sun's full disk and outer atmosphere, the corona, ever taken. Another image taken by SPICE, that's the Spectral Imaging of the Coronal Environment instrument, represents the first full Sun image of its kind in 50 years, and by far the best. It was taken at the Lyman beta wavelength of ultraviolet light that's emitted by hydrogen gas. These images were all taken when Solar Orbiter was further out at a distance of roughly 75 million kilometres, halfway between the Earth and the Sun. The high-resolution telescope of the Extreme Ultraviolet Imager makes observations of such high spatial resolution that at that close distance, a mosaic of 25 individual images are needed in order to cover the entire face of the Sun. Taken one after the other, the full image was captured over a period of more than 4 hours. That's because each tile takes about 10 minutes, including the time for the spacecraft to point from one segment to the next. In total, the final image contains more than 83 million pixels. That's 10 times better than a 4K TV screen display. The Extreme Ultraviolet Imager observes the Sun at a wavelength of 17 nanometers in the extreme ultraviolet region of the electromagnetic spectrum. This reveals the Sun's corona, which has a temperature of around 1 million degrees Celsius. Meanwhile, the SPICE instrument is tracing the layers of the Sun's atmosphere from the corona down to the chromosphere, that's the second outermost layer of the Sun. Several thousand kilometres thick, the chromosphere resides beneath the corona and above the photosphere, which is often described as the Sun's visible surface. SPICE does its imaging by looking at different wavelengths of extreme ultraviolet light that come from different atoms. In the SPICE sequence of imaging, purple corresponds to hydrogen gas at a temperature of 10,000 degrees Celsius, blue responds to carbon at 32,000 degrees, green to oxygen at 320,000 degrees Celsius, and yellow means neon at 630,000 degrees Celsius. This allows physicists to study the incredibly powerful eruptions which take place in the corona right down through the sun's lower atmospheric layers. It'll hopefully also allow them to solve one of the sun's greatest mysteries. Why is it that the temperature of the sun's atmosphere increases with distance from the sun's surface? After all, things are meant to get cooler, not hotter, the further away you get from a heat source. But while the sun's visible surface has a temperature of around 5,800 degrees Celsius, that's soared to over 1 million degrees in the corona. It's a question which has long puzzled scientists. And there's a whole flotilla of spacecraft, not just Solar Orbiter, studying our local star to try and answer that question, as well as lots of others. This report from ESA TV.
The Sun, a 4.5 billion-year-old nuclear fusion reactor at the heart of our solar system. This glowing ball of plasma with a core temperature of 15 million degrees Celsius is a yellow dwarf star. In cosmic terms, it's nothing special. But for us on Earth, the Sun is vital. It holds the planets in their orbits and provides heat, light and the energy for life. ESA's first mission to the Sun, Ulysses, was launched from Space Shuttle Discovery in October 1990. A joint mission with NASA, it was the first spacecraft to fly over the Sun's poles. Ulysses investigated the solar wind, the stream of charged particles emitted by the Sun. It envelops the solar system in a bubble known as the heliosphere. The mission discovered that the solar wind weakened over time and that the Sun's magnetic field reverses every 11 years.
4, 3, 2, 1, ignition, and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
One of the longest and most successful scientific missions of all time, SOHO, was launched in 1995, and it's still going strong. SOHO has given us a new insight into the Sun's structure and interior, monitoring the output of solar radiation and providing the first images of the star's turbulent outer shell. SOHO has also transformed space weather forecasting, helping us to monitor violent solar activity from flares and coronal mass ejections. A major space weather event has the potential to damage satellites, communications and power grids on the ground. Another mission that's helping us better understand the relationship between the Sun and Earth is Cluster. Flying in formation and in orbit for almost 20 years, the 4 cluster satellites are giving us a three-dimensional view of the Earth's magnetic environment and its interaction with the solar wind. Now it's the turn of Solar Orbiter. With its advanced suite of scientific instruments, it'll build on the work of these past ESA missions.
Our scientists have designed this mission so that they improve significantly their knowledge of the solar wind and what drives the solar wind, and as well what creates and generates the solar cycles.
The eventual aim of all these missions is to not only better understand our nearest star, but also predict its behaviour. Knowledge that'll help protect all of us back here on Earth.
And in that report from ESA TV, we heard from Solar Orbiter Project Manager Cesar Garcia. Meanwhile, a spectacular series of solar flares have erupted on the surface of the Sun, sending material and radiation deep into space and triggering geomagnetic storm activity on the Earth. Solar flares are powerful bursts of energy caused by the snapping of magnetic field lines emanating from pairs of sunspots on the solar surface. And this latest activity represented the most powerful solar flares produced by the Sun since the start of its latest solar cycle, number 25. Powerful solar flare eruptions cause coronal mass ejections, which fling billions of tons of solar material, usually ionized protons, electrons and helium nuclei alpha radiation particles, deep into space. And if the Earth just happens to be in the way of one of these, they can impact spacecraft, short-circuiting equipment. They cause radio communications and navigation system problems. They can disrupt power grids, causing blackouts, and increase radiation doses both for astronauts in space and people in high-altitude aircraft. These latest solar flares were detected by NASA's Solar Dynamics Observatory spacecraft, which monitors our local star continuously, looking for these space weather events. Scientists classify solar flares as either C, M or X class, depending on their brightness in X-ray wavelengths. The two flares launched last week were classified as an X-class flare on March the 30th, followed by a slightly less intense M-class flare on March the 31st. And they triggered a remarkable sequence of events, including a towering wave of hot plasma racing across the sun's surface called a solar tsunami, and something called a cannibal coronal mass ejection caused by the fastest second solar flare wave overtaking and consuming the slower first wave. The events also caused a strong G3 class geomagnetic storm when it hit the Earth's magnetic field. And that triggered spectacular auroral activity at higher latitudes. This is SpaceTime. Still to come, NASA forced to scrub the Artemis 1 test, and the James Webb Space Telescope completes the first multi-instrument alignment. All that and more still to come on SpaceTime. Let's take a break from our show now for a word from our sponsor, NordVPN. You know, these days people need to take extra care about what's happening online. They need to be concerned about their online privacy and security. And that is where NordVPN comes in. It helps to protect you and your family from online threats, keeping your identity and data safe and secure. NordVPN encrypts all your traffic so no one can see what you're doing online. Creepy prying eyes don't get a look in. And they have a strict no-logs policy, so you can be sure that your data cannot be shared or accessed by others. And NordVPN has amazing speed. Tests confirm it's rated as the fastest VPN out there, and that means you won't have to wait long for videos and websites to load. You'll be able to surf the web and stream movies with ease. Plus, I found NordVPN to be really easy to use. And we have a special deal for SpaceTime listeners. If you use our special URL, nordvpn.com/StuartGary, and use the code StuartGary, you'll get a huge discount off your NordVPN plan, plus one additional month for free and a bonus gift. And of course, it all comes with NordVPN's 30-day money-back guarantee. So, what do you got to lose? And of course, you'll also be helping to support our show. And I'll include the URL details in the show notes and on our website. And now, it's back to the show.
You're listening to SpaceTime with Stuart Gary.
NASA has been forced to scrub its critical wet test of the Space Launch System SLS Artemis 1 moon rocket. The problem has been traced to technical issues with ground equipment used to fuel the giant 98-metre tall rocket. The issues developed as the mega rocket sat on top of its mobile launcher on Pad 39B at the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida. Technicians had planned to fuel the SLS with 2.6 million litres of cryogenic propellants and oxidizers as part of the 3-day wet dress rehearsal for the launch. However, a key system that uses fans to pressurize the mobile launcher and keep out harmful gases failed, raising safety concerns and halting the first attempt, while a second later attempt also failed because of a stuck vent valve, also on the mobile launcher. A third issue, though considered only minor, was a sudden thunderstorm which saw lightning hit the launch pad 4 times, but that simply proved that the lightning protection system was working. Artemis mission managers say the test will now be pushed back until after the launch of SpaceX's Dragon AX-1 Axiom mission, which is taking space tourists to the International Space Station from Pad 39A next door. Ironically, AX-1's launch was delayed from April 3rd to make way for NASA's Artemis 1 fueling test. But the flight needs to launch now to avoid even more delays due to SpaceX's Crew 4 mission for NASA, which is bringing new astronauts to the International Space Station. That's currently slated to launch on April 20. Axiom's 4 passengers, 3 billionaires who paid $55 million each, plus a former NASA astronaut, will spend 8 days aboard the orbiting outpost. Now, what all this means is that the launch window for the unmanned Artemis 1 mission to beyond the moon will now be delayed until at least July. If Artemis 1 is ultimately successful, Artemis 2 will carry a crew of 4 around the moon in 2024, and then Artemis 3 will return humans to the lunar surface in 2025. We'll keep you informed. This is SpaceTime. Still to come, NASA successfully completes the 6th stage of aligning James Webb's mirrors, and later in the science report, a new study finds that climate change isn't just damaging nature, it's damaging man-made infrastructure as well. All that and more still to come on SpaceTime. NASA says they've successfully completed Stage 6 of aligning the James Webb Space Telescope's mirrors to its scientific instruments. The work means the $10 billion orbiting observatory will create the most accurate and focused images possible, seeing further back through space-time far beyond Hubble to the birth of the first stars and galaxies. While the observatory's mid-infrared instrument continues to cool down, optics teams have been successfully aligning the rest of the telescope's onboard instruments to Webb's mirrors. Previous alignment efforts were so accurate, mission managers have concluded that no additional adjustments to the secondary mirror are necessary until the 7th and final stage, which will involve the mid-infrared instrument once it's fully cooled down. Webb wavefront sensing control scientist Chandra Walker says that as a general rule, the commissioning process starts with course corrections, then moves into finer adjustments. The early secondary mirror course corrections, however, were so successful that the fine corrections in the first iteration of Phase 6 were simply unnecessary. Throughout the majority of the alignment process, James Webb's 18 hexagonal gold-coated primary mirrors and its secondary mirror were focused into alignment with the near-infrared camera instrument only. Completing this latest step means the observatory is now aligned to the fine guidance sensor, the near-infrared slitless spectrograph, and the near-infrared spectrometer, as well as the near-infrared camera. Once the mid-infrared instrument cools down to its cryogenic operating temperature in the next few weeks, mission managers will carry out a second multi-instrument alignment to make final adjustments to the instruments and mirrors as required. When the telescope is fully aligned and able to deliver focus light to each of the instruments, a key decision meeting will occur to confirm the end of aligning the James Webb Space Telescope. The team will then transition from alignment efforts to commissioning each instrument for scientific operations, which are expected to begin around mid-year. The James Webb Space Telescope will see back more than 13.4 billion years to a time in the evolution of the universe known as the Epoch of Reionization. This is when the very first stars began to shine, ending the cosmic dark ages and turning the universe from a translucent fog into what we see today. James Webb will also study the atmospheres of distant planets, looking for chemical signatures of life beyond Earth. And it will open up new, never-before-seen vistas of the universe and our place in it. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. We all know that climate change is devastating the planet's ecosystems, wiping out thousands of species. But what about its likely impact on people who live and work in the Arctic? In a series of 6 separate studies, scientists are showing that climate change-induced melting of the permafrost could have damaging effects on the Arctic's man-made infrastructure. The findings, reported in the journal Nature, show that by the middle of the century, 69% of residential, transportation and industrial infrastructure in permafrost regions will have been affected. And the research shows that the repair bill for all this damage is likely to cost tens of billions of dollars. Well, it seems a koala specially bred as part of a University of Queensland-led conservation project could turn around the fate of endangered koala colonies right along Australia's east coast. 2-year-old Jaeger, the first koala bred in the Living Koala Genome Bank pilot project, has been released into a colony on the southern Gold Coast. The project's a collaboration between the University of Queensland, the Queensland University of Technology, and the Dreamworld Wildlife Foundation. It aims to boost healthy koala genes in local populations threatened by habitat loss and disease. In a major milestone towards rescuing the critically endangered helmeted honeyeater, scientists from Monash University have successfully deciphered the bird's genome. The findings are a boost for genetic rescue efforts for the helmeted honeyeater subspecies, which is the emblem bird for the Australian state of Victoria. The number of helmeted honeyeaters has significantly declined over the past 200 years since the first non-Indigenous people arrived in Australia. But genetic rescue, that is, the introduction of genes from outside the small genetic pool of the endangered population, might be able to provide a solution to restoring the genetic health of the wild population. Apple have announced that this year's Worldwide Developers Conference will be held online in June. It's a chance for developers to talk with Apple about their latest apps and other projects and how they'll work on Apple products. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
They hold it every year in June. The 2022 version will be from the 6th to the 10th of June in the US timeframe, 7th to the 11th in the Australian timeframe. It is again online. A lot of companies still not super comfortable with having in-person events, and Apple has done very well by having its online launches. Obviously, they get to sort of control things. And look, this is a week-long event, so there will be plenty of interaction between the developers and Apple's experts to help developers to create apps and answer all sorts of questions. With an online format, you can have many more people attending. Previously, there was a lottery system for those who could go, but when it's all online, well, anybody can go. There's no cost to it. And of course, we'll see the latest innovations in iOS. It'll be iOS 16, iPadOS 16, macOS should be 13 by then, watchOS, I would say 9, tvOS 16. And people will be looking for improvements in the way that iPadOS works compared to macOS. We will hopefully, at some point in the next year or two, maybe longer, see some sort of a touchscreen Mac that really blends the iPad and the Mac together, even though Apple has said no. Apple has said no to many things in the past that it miraculously launches when it feels the time is right some time later.
Apple have to ask themselves, what would Steve have done?
Well, Apple will do what Steve has done, which is to deny, and then to do exactly what's been denied. They denied they were ever going to make an iPhone. They denied they were ever going to make a tablet. They denied they were ever going to use a stylus. They denied that the iPod would ever have the ability to play video. Steve Jobs said a 2-inch screen is
You told me that we'll do that one day. You knew all that about the convergence of technologies.
Well, everybody knew it. And, the thing is, though, Apple needed to put its competitors off the scent. It needed its competitors to come out with devices so that it could sort of see what not to do. I mean, we've had people like Samsung and Google releasing virtual reality headsets that were then unceremoniously dumped, and Apple is still yet to launch it. I mean, the only really successful headsets are those from HTC and Oculus, which is Meta, Facebook, and they've got the Oculus Quest 2, which is a standalone unit, doesn't require you to have a connection to a computer. I think HTC has a similar unit. We're just starting to see those devices really mature. But when Apple launches its version of that, it should hopefully be a lot more mature, and it should show the whole industry how it's done, and then everyone will then start copying that. Because Apple's normally not the first to launch things, it's the last one, but it launches the version thereof
but
that everyone says,
by the time it launches.
It's sorted. That's right. Yeah, that's right. And one of the things Apple has also done is it created its own programming language called Swift. So there's going to be a big focus on this, as per usual. In the WWDC, I'll be having some sort of a competition to help people to create more advanced Swift apps. It's a Swift student challenge, and with the Swift Playgrounds app for iPad, the last version that launched last year, it was the first time that you could use an iPad to create iPad and iOS and iPhone apps. Previously, you had to do all that on a Mac. So clearly we'll see more of an improvement for that this year. And look, the WWDC, it represents the most advanced thinking from Apple at this particular time. It will launch the latest beta versions of operating systems. Normally, iOS and iPadOS, etc., will be in the developer version for approximately a month before they launch the public beta versions. And many people, including myself, at least on one of iOS devices, I'll be installing the public beta, perhaps even the developer beta, just to be able to enjoy and help bug test and look at and appreciate all of the new features that will by September, October, become natural and normal for everybody.
Now, just before you go, normally you're one of those jet setters who either drive or fly very fast between Australia's national capital, Canberra, and its largest city, Sydney. You've not done this time. You've decided to use surface transportation, the coach and the train. What was that like?
Yeah, well, I travelled by bus on the way up. You get good internet connection all the way on the main highway. And obviously, it's a bit more cramped on the bus, and it's a more direct route because you're going on the freeway. But of course, you then, hit the traffic. But on the train coming back, I did notice that I had, I think, more internet than I remember from the train in the past. But you do spend an extra hour on the train than you do on the bus. Of course, it depends on, how much traffic is on the road. But about, an hour and a half of that is with no internet or very poor internet. So it's amazing that, we still don't have internet on the train line.
Anywhere else in the world, travelling between the nation's largest city and the nation's capital would be a 320 kilometre per hour high-speed journey. Only in Australia do you get to travel in the steam age in the 21st century.
Yes, with a slow journey with a very, very extremely creaky train. I mean, the amount of noises this train was making was unbelievable. Of course, you do tune out of it after a while, but I was getting my meal and somebody was asking me, what's the Wi-Fi password? And I was like surprised. I said, I don't think this train has Wi-Fi. And he was sure, and he went up and asked, and she said, no, this train's 40 years old, there's no Wi-Fi here. And he said, how are you getting online? I said, well, I've got my phone, but I reckon there's a lot of black spots because I remember there being a lot of black spots, and of course there were. So that's the only downside of the train. It's a bit more comfortable than the bus, but some of the way there's no Wi-Fi. You just have to rely on content you already have downloaded or cached on your device. The train does have the amenity of wider seats, a much better table upon which you can put your laptop and do some work, nicer toilets, and you've got a canteen where you can go and get food. You don't have that sort of thing on the bus. It's much more cramped. The bus, though, is on a much more direct path. Get there normally about an hour faster than the train, and you have
all the way. Yeah,
that's right. And you have 3G and mostly 4G all the way. It never goes into no service or SOS. Whereas on the train, about an hour and a half to 2 hours of the journey, the internet's very flaky. You see occasionally when you get to a little country town that you're stopping at that you get 5G, but then it'll go to 4G and then 3G, and there's quite a few sections for half an hour or more that say no service, which seems crazy in 2022 that we have places on major train lines that have no service. So if you want a comfortable journey, the train is there. The train does cost more than the bus, takes longer, but it's more comfortable. So if you're in a hurry, you go on the bus, and if you're really in a hurry, you catch a plane. But normally, getting to the airport, waiting for the plane, getting on the plane, taking off and landing. I mean, even though it's only a half an hour to 45-minute flight, it can sort of all add up by the time, door to door.
We're coming up to an election, and every election, of course, there's the constant promise by both sides of politics. Yes, we'll look at high-speed train between Sydney and Canberra. Hasn't happened this time yet. Probably will as the day draws nearer. Of course, it's a promise they've been making since the 1980s.
Oh, for decades.
Yeah.
I know that in the early 2000s, the then Prime Minister John Howard had the opportunity to build a high-speed rail between, I believe, Sydney and Melbourne for something like $7 billion. Now, the last time I heard about this particular promise back in about 2019 at the last federal election, the cost had blown out to $120 billion. So it was a great shame that the government at the time in the early 2000s didn't build it, because $7 billion, based on today's figures, would have been an absolute bargain. And yes, it would have had the ability to travel between Canberra and Sydney in an hour, which, given all of the need to get to the airport and go through all the rigmarole, would have been basically on par with catching a plane. So it's a great shame. I don't think it'll happen anytime soon. It'll be promised or talked about, I'm sure, but it probably will be decades before it happens. And by then, we'll probably have invented teleportation and we won't need it.
Yes, beam me over, Scotty.
Can't wait for that.
That's Alex Zaharov-Reutt from ITWire.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.